Okay, types of chemical bonds. First of all, why do chemical bonds form? They form because they lower the potential energy between the charged particles that compose the atoms. So atoms have protons and electrons in them. Those are charged particles. And when a bond forms between two atoms, it does so because that's more stable, it's lower in energy. As atoms approach each other to form a bond, there's a very complex set of interactions. We've got electrons repelling each other. We've got nuclei repelling each other. But then we have the electrons and the nuclei attracting each other. So it's kind of complicated. So the bond will form if those interactions result in a net reduction in energy. So ionic bonds are between metals and nonmetals. So metals have low ionization energies. It's relatively easy to remove an electron from them, and so then the metals form cations. Nonmetals have negative electron affinities, so they're going to gain electrons and form anions, and now we have charged particles, a positive and a negative, and those are attracted to each other. So the reaction occurs because the metal transfers its electrons to the nonmetal. The metal's interested in losing some electrons, the nonmetal's interested in gaining some electrons. They get together and they make each other happy, I guess. Then you have oppositely charged ions and you just have electrostatic attraction. So this little table here is giving us a summary of three types of bonds: ionic, covalent, and metallic. Ionic bonds, what we're talking about just here, are between metals and nonmetals, and we get electrons transferred from one atom to another. Covalent bonds happen between nonmetals with each other, and because the nonmetals aren't interested in losing electrons, nobody's willing to become a cation, and so instead of transferring electrons, they share electrons. And then metallic bonds are the bonds within a metal, a piece of aluminum, or between different metals in an alloy. And we'll talk about this at the end of the chapter, and this is where electrons are pooled. They're not really shared, they're just kind of put into a collective pot. So the covalent bonds are sharing of electrons. So the shared electron interacts with both nuclei. And so the most stable arrangement is where the electron is between the nuclei, right? Because here you've got maximum attraction for each nucleus. Here you're further apart and you've got less attraction. So this is the most stable. And over here, this is rather unstable. The electron's really far away from this one. So the potential energy gets lowered by this sharing of electrons. That shared electron attracts the nuclei to each other and holds them together. Metallic bonding, well, I guess I lied. We're not just talking about it at the end. I'm going to talk about it right now. This occurs between metal atoms. Metals lose electrons easily to make cations, but then you got a bunch of cations that are not going to be attracted to each other. The simplest model for metallic bonding is called the electron C model. And the idea here is that all the atoms in that piece of metal, they're arranged in a lattice, a three-dimensional pattern. They're all going to pool their valence electrons. It's like, okay, well, here are my valence electrons that if I was interacting with a nonmetal, I would transfer them to the nonmetal. But nobody around me wants these, so I'm just going to put them out there, and we're just going to let them run around. And the electrons are kind of all around, and the positive ions are attracted to this pool of electrons, and it kind of holds these things together. The electrons get delocalized over the entire metal. I don't think I have a picture here. I think of this a little bit like the nuclei or the individual atoms are houses in a neighborhood, and electrons are a lot like little boys, like Andrew. They're kind of squirrely, right? And so what's happening here is nobody wants my two little boys to come over to their house to play, and I don't want anybody else's little kids in my house because I just vacuumed or something, right? So we're going to send them all outside. They're all sent out to play. This is what used to happen. When I was growing up, they just said, go outside and play. Come back when the streetlights come on. And that was it. It was a different world. But when you have neighborhood kids running all over the place, then if you're inside and you hear a kid screaming, you're like, hey, wait a minute, that could be mine, or it could be so-and-so's. I know these people. I'm going to go out and find out what's going on. So it pulls together the neighborhood because everybody's kind of watching out for everybody else. So that's kind of what metallic bonding is, the electron C model.